Okay, we are just going to do a little bit of a discussion about scale. We haven't really focused on that too much in this part of measurement, so I'm just going to quickly go over it. The most important thing to remember, let me just write this, scale. Okay, most important thing to remember, if you have got any scale, so if I've got 1 to 100 here, is that this part here on the left hand side is the representation unit. Okay, so we'll write that. And that this is the real unit. So obviously you know that if we have got a drawing that we are representing something that is real by drawing it at a different scale. And if we always remember that the left-hand side is the representation and the right-hand side is what the size is in real life, then you can't really get into too much trouble. So essentially, scales that we use when we're doing drawings or if we're making models, we use scales like 1 to 500, 1 to 100, 1 to 50, 1 to 20, 1 to 10, 1 to 2, etc. Okay, if you are looking at maps, you might see scales like 1 to 500,000 and 1 to 1 million. Definitely use those in geography. Okay, so obviously they are scales where you are looking from a great distance. Okay, so what this means is that the drawing or the representation is much smaller than what we have in real life. Okay. By the same token, though, we can have the opposite, where the representation is larger. So if we are looking at doing a drawing of a piece of jewellery, or if we are looking at a piece of electronic equipment, or if we're going to, in science, perhaps do a cross-section of a leaf, something like that, we might need a scale where we have got 100 to 1, or 50 to 1, or 2 to 1. But the same rule applies. Okay, we have got our representation here, and we have got our real life on the right hand side. Okay, so that is as complicated as this gets. If you remember, the left hand side is our representation and our right hand side is the real life, we can pretty much talk through any problem if I have got a scale of 1 to 50 and I have got a question that asks me about, I have a measurement of 30 millimeters on a drawing, what does that represent in real life? I think to myself, I have 30 millimeters in that is represented. And on this side, I want to know what is it in real life. Okay? So what we're going to do is we're going to take this and we are going to multiply it by 50. Okay. 30 times 50 is 1500. So at a scale of 1 to 50, 30 millimeters represents 1500 millimeters or 1.5 meters. Okay, so if I get a ruler, which really shouldn't be as difficult as it is, and I draw 30 millimeters. Oh, I don't know if I can do that. No, I don't know if I can do that. If I draw a line and I measure 30 millimeters on it. No, not happy about that. Yes, here we go. 30 millimeters. Okay. In real life, that would be 1.5 meters or 1500 millimeters. Okay, so if we're going to go in the other direction and we know the dimension in real life, okay, so say we've got a veranda that's 3 meters wide, okay, and we want to know how wide to draw it or what length to use to represent that on our drawing. We think, okay, we've got our real measurement here and we want to know how to represent that. Okay, so what we're going to do is we look again at our scale, 1 to 50. Okay, just to explain what I did before. If I divide 50 by 50, I get 1. Okay, if I multiply 1 by 50, I get 50. Okay, so in the previous example, what we did was we took our 30 millimeters here and we multiplied it by 50. We multiplied it by 50, just as 1 has been multiplied by 50. Okay? What we need to do here is look at how we are going to make 3,000 equivalent to the 1 to 50 scale. So just as we have divided 50 by 50, we are going to divide 3,000 by 50. Okay, so let's look at that. We go divided by 50. So 3,000 divided by 50 actually equals 60. Okay, so when we rewrite this ratio here, it is 60 is to 3,000. So 60 millimeters represents 3,000 millimeters at a scale of 1 to 50. Okay, so by following that rule of the left hand side is the representative or the drawing or whatever you might like to call it, and the right hand side is the real side, looking at what you have to do to one side to achieve the other. You can fairly simply solve any scale problem that's going to be thrown at you. Okay, I hope that helps.